Several theories about the structure of the universe. 1. The theory of relativity. It states that nothing in the universe can move faster than the speed of light. Moreover, it shows that the passage of time is different for people moving at different speeds. And here's where it gets interesting. According to this theory, if you separate two twins, leaving one on Earth and sending the other into space to travel at a speed close to the speed of light, then when they meet, their ages will differ significantly. Again, significantly. This idea is wonderfully illustrated in the film Interstellar. This film is definitely worth the 3 hours you will spend in the company of Matthew McConaughey and surrounded by a variety of scientific theories described in simple terms. Let's return to the theory of relativity. In truth, movement close to the speed of light is hardly feasible in practice. Nevertheless, even if you are walking with a friend and they are walking slightly faster than you, time passes more slowly for them. Of course, the difference is so small that you will never notice it, but it exists. That is why, as they say, if you want to stay young, keep moving. 2. Moleholes. Imagine that you need to get to a certain point in space that is very far away from you. In fact, literally every point in the universe is very far away, because with the current level of technological development, even a trip to the edge of the solar system is a very long journey. In such a scenario, you really want to cut corners to get to your destination sooner. And this is where the idea of moleholes comes in. As it turns out, Einstein's general theory of relativity allows for the existence of black holes which serve as bridges between different parts of the universe, or even as gateways to other universes. Such a bridge has the shape of a tube connecting different points in space-time. And if we simplify space to a two-dimensional model and imagine it as an ordinary curved sheet, then a wormhole is an open tunnel, the shortest path between its two halves. Obviously, this method of travel is much more efficient and rational. Unfortunately, wormholes remain a theoretical model that we have not yet encountered in reality. Nevertheless, theoretical models sometimes become surprisingly good aids to imagination, and the film Interstellar, in which wormholes are one of the main scientific concepts, is a perfect confirmation of this. 3. The fate of the universe. There are several basic scenarios for the end of the universe. Big Crunch, Big Bang. Most astrophysicists agree that the universe began with the Big Bang. Before that, it was concentrated in a singularity, a point of infinite density. The Big Crunch scenario assumes that one day the expansion of the universe will be replaced by the opposite process, contraction, and everything will go in reverse. However, many physicists do not take this theory seriously, since at the moment the universe is expanding, and doing so at an accelerating rate. Therefore, speculations about when this will end have no qualitative basis. Heat death. This is the exact opposite of the Big Crunch. The theory suggests that the expansion will continue, and eventually, all that will remain of the universe are elementary particles flying randomly through space. The universe will literally be torn into tiny particles. The fact is that, according to the laws of thermodynamics, entropy in any closed system increases, which means that sooner or later, all matter will be distributed throughout the universe as elementary particles. All stars will go out, and there will simply be no energy left to ignite new ones. When time stopped. This is not the most popular theory, but it is still very interesting. Think about it. Is there anything infinite in the world? If you ask a large number of people this question, the most popular answer would probably be time. Indeed, one moment must differ from another. Everything cannot freeze in one moment. Once and for all, can it? Let's assume that the universe will exist indefinitely. In that case, everything that can happen will happen. In reality, such an assumption contradicts many calculations. Therefore, scientists have put forward the theory that time itself is finite and will eventually stop. Perhaps one day we ourselves will not feel or understand how the beginning of our infinite life, which has no meaning, will begin. 4. The ekpyrotic scenario, cosmological scenario. It is possible that our universe was born somewhat differently than many people imagine. According to the cosmological scenario, there are two three-dimensional worlds separated from each other by an incredibly small distance, less than the diameter of an atom. Each point in one world is adjacent to a point in the other world. These worlds are slowly moving away from each other while expanding. But at certain moments in time, these worlds collide, creating a new Big Bang. This happens constantly and cyclically, generating an endless series of Big Bangs. 5. The gay hypothesis. This hypothesis was formulated in the 1960s by scientist James Lovelock, who called the Earth a self-regulating organism. This does not mean that the Earth is actually alive. It just consists of complex components that interact very successfully and skillfully. According to the Gaia hypothesis, these interactions work so harmoniously that they maintain the Earth in a state necessary for the preservation of life. James Lovelock himself proves the hypothesis with at least the facts that the Earth's surface temperature remains very stable despite the increase in solar radiation. He also noted the constancy of ocean salinity and atmospheric composition, despite the fact that this should have thrown them out of balance. 6. The anthropic principle. This idea is based on the fact that the universe is exactly what we need for life. This is quite surprising, considering that life would not exist if any physical constant changed by even a fraction of a percent. This raises the question, if the universe is ideal for us, perhaps it was created for us. There are two anthropic principles, weak and strong. The weak principles states that the universe only allows for the emergence of life. That is, we can replace the question, why is the universe the way it is, with why is the universe such that intelligent beings have emerged in it, who ask questions about the reasons for the structure of the observable universe. Or, to put it more simply, we already assume that intelligent life originated in the universe. If it did not exist, no one would ask why the universe is the way it is. The strong principle asserts that the universe must be structured in such a way that life can arise in it. In support of this unproven hypothesis, it is argued that there is a certain law according to which all physical constants must equal the values they equal, and they cannot differ from them. Thus, the weak principle is just a good exercise in logic. We live because we live, while the strong principle is a real field for debate and discussion. If you liked it, give it a like. Subscribe to the channel. There's a lot more interesting stuff ahead.